Okay, let's go ahead and finish this bad boy out. These are the last two pages of the sort of the review packet that I made by cobbling together a bunch of pages from tests of years past. And the next two net change theorem problems are similar to the one before it. And I guess I just haven't been too creative with net change problems as I've given them on tests, or perhaps I just kind of wanted to give ones that were rather straightforward. I will probably do the same for you guys. It'll probably be something very similar to this. Particle motion, something polynomial where it doesn't require a whole lot of energy to do what it is that I'm asking you to do. Let's go ahead and get started on this one. A particle is moving along the x-axis at a velocity modeled by v of t is equal to 2t squared minus 5t plus 2. If the particle is at x is equal to 4 when time is equal to 0, then where is the particle when t is equal to 5? What is the total distance traveled during the time interval? Now, if you notice, this was basically the same exact thing as I asked in the last question, just asked differently. Okay, with the one exception of I'm giving you a starting point. Okay, but if the particle is at x is equal to 4 when t is equal to 0, then where is the particle when t is equal to 5? That's basically asking you what is the displacement. Oh, by the way, then add it to 4, okay? So let's go ahead and find the displacement from 0 to 5. So 0 to 5, and I have 2t squared minus 5t plus 2 is dt. Okay, and I'm going to get 2/3 t cubed minus 5/2 t squared plus 2t. And we're going to do it from 0 to 5, which basically, when I plug in 0, they're all going to be 0. So I'm really just evaluating 5. And I get 2/3 times 125 minus 5/2 times 25 plus 10. Okay. Now let's go ahead and use our trusty calculator to evaluate this and get the fraction. So let's go ahead and do alpha f2. Pick 4, which is integrate. I'm going to go from 0 to 5 of 2x squared minus 5x plus 2 dx. Let me make sure that I did that right. Yes, I copied it down correctly. And then we get this. Now, of course, like I've said before, you can swap it into an improper fraction by going to alpha f1 and picking option number 4, and I get 185 over 6, okay? So I have 185 over 6, which is approximately 30.833, okay? Now that's how far it's traveled. It obviously traveled in the positive direction because it is a positive net change in distance. So basically what I need to do is just simply add 4 to this. So the particle traveled 34.833 units. Okay? And there we go, right? Now, that was part A. Now, it isn't labeled A and B, but for the sake of just, organizational interests when we're displaying our answer, which some of you could, work on a little bit. What is the total distance traveled? Well, now we need to figure out whether velocity changes sign somewhere in there. And that means that I need to find out if there are zeros in there, okay? And the only way for there to be a 0 in there, which means, or the only way for there to be a rational 0, is for this to factor with, since 2 is prime and 2 is prime, it's 2 and 1, 2 and 1. How they match up, now this is positive, so this is negative, so both of them are negative. But I know that a product of 4 and 1 will give me my -5 right here in the middle. So I recognize the fact that it actually changes sign twice. it changes sign at 1/2 and 2, which are both inside of that particular interval. Now, this is an upward-facing parabola, so basically it's going to be positive, okay, velocity, basically from 0 to 1/2, and then from 2 to 5, okay? It is going to be negative velocity from 1/2 to 2, right? It has to be because it's an upward-facing parabola. It's going to dip below the x-axis between 1/2 and 2. Okay, well that tells us that these two, the integrals basically represented by these two intervals are going to be positive, and then I need to unnegativize. Oh, sorry. I need to move that up. I need to, basically these two intervals and the integrals that are represented by them need to be positive, need to stay positive. This negative one needs to be basically unnegativized, okay? Now, in a certain sense, you could just do this interval since you already have the net change, right? You could do this because you could basically figure out what it was that was the negative portion of this, okay, and then add it back, and then add it back again in order to basically turn it positive. But let's go ahead and just set up the whole thing, okay? Let's go ahead and sort of draw lines to sort of portion this out, and what I'm going to get, and I'm just going to write it as v of t instead of doing it as the whole thing. So I need from 0 to 1/2 v of t dt. I need 1/2 to 2 of v of t dt, and I need 2 to 5 of v of t dt. These two were positive velocity. Those are the intervals where the velocity is positive, so the accumulation will be positive. This is the only interval where the velocity is negative, and therefore the accumulation will be negative as well. I need to unnegativize it. I need to turn that negative accumulation positive such that it actually accumulates the way that I really want it to, okay? Now, that means that what I'm going to get is I'm going to get, 2/3 t cubed minus 5/2 t squared plus 2t from 0 to 1/2 minus, or that's going to be plus, let's go ahead, minus 2/3 t cubed minus 5/2 t squared plus 2t from 1/2 to 2, and then add again the 2/3 t cubed minus 5/2 t squared plus 2t, 2 to 5. And of course that's going to be incredibly tedious to do all of the arithmetic, but basically let's go ahead and just do it with our calculator really quickly. I have the one from the last video still stuck in here, and I only have to change a couple of numbers for it to work for us here. Now we have v of t that we were given in our y1, and so let's just do the integral from 0 to 1/2 of y1 dx minus the integral of 1/2 to 2 of y1 dx plus the integral of 2 to 5 of y1 dx. And this should give us, that gives us 33, so we get 33.083. Okay, and if I wanted to actually put that into a fractional form, it winds up being 397/12. Okay, and that is the total distance. And so basically this right here, since the difference between this total distance and this net change means is right about, gosh, it's not even 2.2 it's 2.2-ish. That means that this middle one right here was actually right about 1.1. Here, I'll show you. Let's just do the middle one again. Okay. Okay. And that's because what happened is what these two were by themselves, in this case, this number was added, and in this case, it was subtracted. Okay, so the difference between the net change, or the displacement, and the total distance, half of that basically, if you chop that in half, that is the negative that you needed to turn positive. Okay, let's go ahead and flip on over to the next one. And again, we get one that is in terms of velocity and particle motion. Gosh, I'm boring when I'm writing these tests. Alrighty, the velocity function in meters per second is given for a particle moving along the line. Find the displacement and the distance traveled by the particle during the time interval. Okay, let's sort of split it up, and let's do the displacement over here on the left-hand side, and let's do the total distance over here on the right-hand side. Okay. Now, the displacement should be relatively simple. Okay, you just need to integrate it. Okay, you need to take the polynomial as you've been given, or whatever the form of the function is, and you need to basically do 1/3 t cubed minus 1/2 t squared minus 6t, and then you need to evaluate it from 1 to 5. Let's go ahead and draw a dividing line down the middle. And basically, you're going to have 1/3 times 125 minus 1/2 times 25 minus 6 times 5. And that's when you're plugging in 5. And then you're going to have 1/3 minus 1/2 minus 6 when you're plugging in that. Now, the fact that this works out, it might actually simplify really well, because these fractions might help each other out. So what I have here is I can actually reorder this if I distribute that negative, and I'm going to get 125 thirds minus 1/3, negative 25 thirds. Actually, let's go ahead and put the negatives up in the numerator for all of these, or negative 25 halves plus 1/2, right, minus 30 plus 6. Well, this right here, oh, sorry, okay, you get what I'm saying. That's negative 30 plus 6. I don't have to deal with undoing that negative and sort of factoring the negative out, so I won't group those together. But here, I have 124 over 3, okay? That actually doesn't wind up helping out a whole lot, because 124 over 3 doesn't reduce, but 24 over 2 does. Okay, so that's minus 12 minus 30 plus 6. And so what I'm going to get is this right here. If it were 123, then it would be 39. Because if it's 120, then it's going to be 40, then 41. Okay, so 41, 41 and a third. If I have 41 and a third, that's 47 and a third. I hate mixed numbers, but there you go. Minus 42, and therefore you have 5 and a third, which is 16 thirds. Okay, so that basically is the displacement. And of course, you write a little bit smaller on this, since you're not going to be doing it for a display and all that sort of fun stuff. Now, if I get over here to total, or if there's a calculator allowed, whatever, I'll try to give you enough room on the test. I'll bump it down a little bit in terms of the formatting. Over here, in terms of total distance, I need to determine whether the velocity changes sign in there. Now, you ought to be able to see the fact that v of t does indeed factor. Okay, that's t minus 3 and t plus 2. t is equal to 3 is where it's going to change sign. Okay, it changes sign at -2 and 3. Now this is an upward-facing parabola, so you know that between -2 and 3 is where it's going to be below. So basically from 1 to 3, it's going to be a negative velocity. From 3 to 5, it's going to be a positive velocity. So you basically just need to pull this into two different ones, and I'm going to express it in terms of v of t instead of the actual polynomial. So what I have here is I have from 1 to 3 v of t dt, and I have 3 to 5 v of t dt. Velocity is positive here and negative here. So the total distance, I'm going to take the negative and unnegativize it and add it to the positive. Okay. This one I'm not going to do the arithmetic and toil away. I'm going to go ahead and use the calculator for it. So let's go ahead and plug it in. X squared minus x, minus x minus 6. Let's go back to the home screen and let's do negative integral from 1 to 3 of y1 dx plus the integral from 3 to 5 of y1 dx, and we get a value of 20. Okay, total distance is 20. Okay, displacement was 5 1/3, which means that which basically means that these were 5 1/3 apart. Okay, let's go and actually just for the sake of, because it's here. Here was the extra credit problem that I put on. Here's an extra credit problem that I put on this test. Now, if you have secant squared tangent and you have secant squared tangent, you can change them in these ways, right? Pull a secant out, okay? And you don't know how to do this quite yet, but basically both of these are legitimate answers. Both of them. The reason is that either one of them can be changed, okay? Either one of them can be changed. Now remember, secant squared is 1 plus tangent squared x. And then basically what you get is you get 1/2 plus 1/2 tangent squared x plus c. Well, that can just be thrown in with the c, which stands for any old constant that you need it to be. And it's the same thing over here. If you have secant squared x minus 1 plus c, you're going to have 1/2 secant squared x minus 1/2 plus c. The negative 1/2 can be combined with the c and just be c, because c stands for just some constant. So there is a little bit of freedom in terms of some of these, and I thought that that was kind of neat. The fact that this demonstrates sort of the way that trig IDs still inform the way that we do some of these, and the equivalence between disparate answers that we might actually arrive at because of the way that we can do that, which I thought was kind of cool. If you don't think so, then there's something wrong with you. That basically brings us to the end of our test review videos. I hope these are helpful, guys. Yeah, look for the posting for the test under an assignment, and please do follow the instructions. And I will, of course, see you on Tuesday. Bye-bye.